All right, so I'm going to take you through the beginning here of simple machines. This is going to be a couple of part video here because this is quite a long unit and presentation and so forth. So I'm just going to take you through some mechanisms and some very simple calculations about mechanical advantage. So here are the three of the six simple machines that we're going to be checking out here. We have a lever, wheel and axle, and a pulley. And the basic job that they do is they multiply um, force and distance. You can change the magnitude of force and distance and create a system to kind of do what you want it to do. The other three simple machines are the inclined plane, the wedge, and the screw. So let's talk mechanical advantage. Mechanical advantage is a ratio of the magnitude of the resistance and effort forces. Now, in plain English, what that means is the magnitude is the amount of force that you have, and resistance and effort forces. Resistance force, think of it this way: if you're picking up a box of books on the ground, the resistance force would be the weight of the box, and the effort force would be the amount of force you need to pick that box up. So it's a ratio of the amount of force the box weighs and the amount of effort that you need to pick it up. It's also a ratio of the distance traveled by the effort force, you moving, and the resistance force, the object that is being moved. These calculated ratios can allow us to manipulate the speed at which something happens, the distance it moves, the force that it's applied, and its other functions such as the direction that it moves. Here's an example of a mechanical advantage of 4 to 1. What does that tell us about this mechanism? So we have a ramp, or excuse me, an inclined plane as our simple machine here. And if you take a quick look at the boxes, you'll notice that they both have blue arrows. They both have red arrows, but one of those red arrows is significantly smaller than the other. So we talked about magnitude of force in the slide before this. The effort force is 4 times less than the resistance force in this application. So you'll see that's why that red arrow is significantly smaller. Okay, in physics, when we draw forces, the longer it is, the more magnitude it has. So you can see just by using that simple graphic there that it's going to take you significantly less effort to push this box up the ramp than it would be to pick it straight up. Okay, the distance traveled by the forces, you can see that if you pick the box straight up, it doesn't move that far. But if you slide it across that inclined plane, that ramp there, it moves a little bit further distance. Okay, it actually moves 4 times the distance because we have a mechanical advantage of 4 to 1. So work. We've talked about work several times in class up to this point. At this point, work is going to be force times your parallel distance. So sometimes when we were talking about torque and horsepower and things like that, we were doing moments and we were working with perpendicular distances. In this application, for all of these simple machines, we're going to be looking at work in a parallel distance. Okay, parallel to the force that's being applied. Okay. The work that's done here is exactly the same regardless of the mechanical advantage. So if you look at the box that's lifting straight up, its force times distance, whatever that may be, is exactly the same as the force times distance for the box that's sliding up the ramp. So those two things are equal. Okay, mechanical advantage ratios. 1 is the magic number. Okay, if a mechanical advantage is 1, that means whatever effort force you're applying, you're moving the same amount of resistance force. Okay, your mechanical advantage is 1. If a mechanical advantage is greater than 1, you need less effort to overcome the resistance, and you need a greater distance. So there's your trade-off. You can lift something up that's much heavier than you could possibly lift, with a really long lever or something, but your distance is going to have to be greater. If a mechanical advantage is less than 1, you need a greater effort force and you need less effort distance. It can never be 0. So there's 2 types of mechanical advantage calculations. There's ideal mechanical advantage. This is a ratio of the distances that are traveled by your effort and resistance. When we use the symbols D sub E and D sub R for effort and resistance. Distance, effort. This is distance effort, and this is distance resistance. It's used in efficiency calculations and safety calculations. It's a theoretical calculation because it doesn't take into account things like friction. So there you go for IMA. AMA is the actual mechanical advantage of a system. This is you need to know 2 of the forces that are being applied here. Sometimes for like practice purposes we make those up. Other times in a lab we're going to actually measure these. With the vernier software, we can measure them with a fishing scale. We can measure them with those little spring scales that you have in physics classes. It's a ratio of the force magnitudes. Now this one's backwards, or upside down rather. It is the resistance, the force of the resistance divided by the force of the effort. Okay, so IMA and AMA. Can you think of a machine that has a mechanical advantage of greater than 1? The example in the PowerPoint is those wind turbine blades. Okay, you have a very large wheel and a very small axle. That's a wheel and axle. And basically what happens is as those propeller blades turn inside, they're creating much more torque, much more speed also in there to turn a generator. What about a machine that has a mechanical advantage of less than 1? Here we look at this workout equipment. So this would be an example of where you'd want to only be able to stack up a small amount of weights, but actually have the user get the effect of pulling more weight so they can build muscle and get themselves in shape. Formulas. The IMA and the AMA formulas I just copied over from the other slide. Okay, and up to this, you should be able to do everything with those 2 formulas. This circular formula here, I just rearranged it a little bit and put it into that. For those of you that have seen that and used that and like that a little bit better. Later on, we can talk about knowing the mechanical advantage and one of the other 2 variables there and calculate the other. That's one method of doing it. So let's talk calculating IMA. 3 of your friends are sitting on one end of a seesaw. So we're talking a lever here. Combined weight is 275 newtons. The length from the fulcrum to your friends, the fulcrum is where the lever is basically still. That's the tipping point on a seesaw. The length from the fulcrum to your friends is 2.5 meters. The rest of the seesaw from the fulcrum to you is 4.5 meters. So what is the IMA? We're going to pull our formula down. We're going to substitute the 2 things. Now, this is where being able to determine what the distance effort is and the distance resistance is a little bit important. The effort is U. Okay, I always look at the effort as being U. So you are 4.5 meters away. Your friends who you're trying to lift up are 2.5 meters away. And if we math that together, we get 1.8. There are no units for mechanical advantage because the units will cancel here. Calculating AMA. So here we have a 15 Newton spring scale pulling a block up an inclined plane. And if that block was going to be lifted straight up, it would require a force of 35 newtons. So AMA, you're dealing with forces. IMA, you're dealing with distances. So let's talk here force resistance. That's going to be your 35 newtons. And your effort force is going to be a 15 newton. So 35 over 15 gives you 2.3. And there you go. Again, no units on a mechanical advantage. So again, pretty simple. The hardest part here is determining what is your resistance and what is your effort, and that comes with practice. Also, feel free to ask questions if you have them. And that's where we're going to stop today. for this. Let me see if I'm still recording here. I think I am. So what I'm going to do is I'm going to give you this mechanical advantage practice problems. I want to say there's only 6 of them. Yep, there's only 6 of them. Again, I put the formulas up here for you. Some of them will require you to find the AMA. Some of them will require them to find the IMA. I think everyone can edit this and write on it on their iPad. If not, you can write it on a piece of paper and submit that, turn that in. But again, if you have any questions, any issues whatsoever at all, feel free to reach out on an email or a Google Classroom comment away. So hopefully you'll take a look at this, and it shouldn't be too difficult. I would suggest rewriting the formula down here in each one of these areas before you go and try to decipher what numbers go where. I tried not to give you too much extra information. Well, number 4 has a little bit of extra. You don't really need to know that 250-pound load. But good luck, and let me know what you think. Thank you.